In this tutorial, I'll show you how to sculpt in Blender 2.8. This is going to be the first tutorial in the series. I'll be covering the following topics in this tutorial. How the sculpting works in Blender. What we need to prepare, if we want to sculpt an object. What kind of sculpting methods are available in Blender? How to properly merge objects prior to sculpting. What are advantages and disadvantages of different sculpting methods available? Then I'll show you how to model this cartoonish penguin character mesh. To be honest with you, this character was accidentally created while trying to demonstrate how to sculpt. It's that easy to make models with sculpting in Blender. In this tutorial series, I'll show you every detail and secret you need to know in order to master sculpting in Blender. Let's begin. Oh, look. This is a cube. If I wanted to sculpt this cube, all I need to do is just clicking that Sculpt tab at the top, right? Why don't we just try doing that? Alright. I'll select one of these buttons and test to see what they do. Nice. We can change the radius of the brush over here. Strength as well. Let's test to see if the shortcut is identical to the texture painting brush. It is. F is used to change the radius of the brush, and Shift F is used to change the strength. What we need to do is. Wait a minute. The screencast was turned on, and it's not working on this tab. Let me turn it off, and turn it back on. Alright, it's working now. What if I go back to the Layout tab? Not working anymore? Okay. Then I'll go back to the Sculpting tab. Alright then, this looks like a bug. Anyway. Let's test the brush shortcut once again. F is for brush size and Shift F is for strength. We can change them on the menu as well. Let's use the brush by left-clicking on the cube. We should be able to use the brush as if we're texture painting, right? Wait a minute. What's going on here? How come I can't sculpt? Maybe it's the brush? Maybe something's wrong with this face. How come this is not working? Let's use other brushes. Maybe they'll work. That didn't work either. What's going on here? Let's flatten this edge with this flatten brush. Nope, not working. Let's grab this face and try to move it. Not working. Can you guess why this is not working? It's not working because there's no vertex to move. All vertices are located in the corner on this cube, and we can only paint and move the vertex with our sculpting brushes. If I use the grab brush to move this vert, it will move without any issues. That's because, again, we were moving a vert. What does this mean? Does this mean we need to add more verts to our cube mesh? How do we go about adding more verts in order to sculpt? This would be the easiest way. We can add a subdivision surface modifier and try to sculpt. This should work, because we added a lot of vertices to our mesh, right? Wrong. The sculpting only works when we apply the modifier. Unless the modifier is applied, the sculpting won't work no matter how many times we've subdivided the mesh. I'll show you what happens in the wireframe mode, when we use the brush. As you can see, it's the vertex being affected by our sculpting brush. This is how the sculpting works in Blender. There are mainly three ways of increasing the vert for sculpting. One is to subdivide after right-clicking in the Edit mode. Another is to apply the subdivision surface modifier. The last one is to use the multi-resolution modifier. The multi-resolution modifier works like this. When you subdivide a mesh using the multi-res modifier, you can do something the other two methods can never do. That is to go back down to a lower resolution state. What is so great about going back to the lower state, you might ask? That feature is great for baking, if you're a game developer who needs to bake your texture in order to use your low polygon mesh with high polygon textures. Also, it's good for editing the mesh as well. I'll show that example in future sculpting tutorials. Another great advantage is not having to apply the modifier in order to use the sculpting feature. Yes, you heard me right. Blender allows the multi-res modifier to be used while it's not applied by the design. That gives a great flexibility in terms of modeling and baking later in the development. The multi-res modifier provides the best non-destructive environment for both polygon and sculpt modeling in Blender. However, the multi-res modifier has a major disadvantage. That is, unlike the dynamic topology sculpting method that I'm about to show you, multi-res method is lacking ways to generate new verts. For example, if we use a snake hook brush to extend our mesh in the multi-res environment, we can extend the mesh, but that mesh won't have as many verts as we've extended the same mesh using the dynamic topology sculpting method. This annoyance that occurs while rotating the mesh in the multi-res environment can be fixed by disabling the fast navigate like this. So in order to make a good multi-res mesh, either you need to only use the multi-res modifier on a complete base mesh that doesn't need to be modified any further, or use a good merging method for additional mesh that need to connect to the current mesh being sculpted. That brings us to the next topic of how to combine multiple meshes properly. Let's take a look at the dynamic topology sculpting method, before we start to merge objects prior to sculpting. In order to use the dynamic topology sculpting method, all you need to do is clicking this DynTopo check button. We'll see this warning message, because our meshes have a default UV data embedded. Blender is showing the warning, because our UV might become useless if we start to sculpt the mesh. If we don't remove the embedded UV data, this message will appear each time we activate the dynamic topology. So, how do we stop this annoyance? If you go to the UV editing tab, you'll see the embedded UV data that came with the default cube. Go to Object Data, UV Maps and press the minus button to remove the UV data, like this. If we go back and click the same button, we'll not see the warning message again. So, what does the dynamic topology sculpting method? Do you remember how the fresh cube had no vert on the surface other than in the corners, so we couldn't sculpt? That won't happen with the dynamic topology sculpting method. Because the dynamic topology sculpting method creates new verts as you sculpt like this. Depending on brush size, brush strength or dynamic topology settings, you can generate more or less verts as you sculpt your mesh. This is great advantage of the dynamic topology sculpting method. The major disadvantage of this method is how it's generating way too much detail while sculpting. Also, compared with the normal sculpting method, the dynamic topology sculpting method requires extra steps such as enabling the option each time we go to another tab and come back, or seeing the UV warning if we don't remove the UV data. I'll show you what happens when we go back to the Layout tab and come back to the Sculpt tab. Did you notice how the dynamic topology check mark was turned off on its own? I'm not sure whether this is a bug or not, because sometimes the dynamic topology check mark appears to be on, even when we go to other tabs and come back. Do you see that? Now the check mark stays for some reason. In later video, you'll notice it turns off on its own when we go to another tab and come back. You can sculpt in Blender like this. First, select the brush you wish to use. By the way, I'll cover all brush functionalities in the next tutorial. Second, you need to set the brush size and strength. Third, you can left-click to apply the brush on the surface. Fourth, you can Control-click and drag to reverse the effect. For example, if you were using a crease brush to but creases on the surface, you can Control-click and drag to create sharp edges on the surface. Fifth, you can Shift-click and drag to smooth the mesh. Unlike the normal sculpting mode, the dynamic topology sculpting mode requires the user to put a check mark on the smooth shading button in order to see the smooth state. Now the object merging lesson begins. Suppose you were to create a character base mesh like this, in order to sculpt. This character looks good and detailed, doesn't it? That was a joke. Let's continue. Suppose we were to sculpt the head. We need to go to the Sculpt tab and start sculpting the head, right? Let's duplicate this mesh, because we might go over the undo limit while doing this. So again, we're going to sculpt the base character's head now. How come this is not working? We turned the dynamic topology on, didn't we? That doesn't work, because before we visited the Sculpt tab the only selected mesh was the character's body. Unless all objects are properly combined, only the selected mesh is going to be sculpted by the design. Let's join all meshes with Ctrl+J, and see what happens. The dynamic topology turned off on its own again. Let's sculpt. What's going on with our symmetry here? Let's go back to the Layout tab and investigate. Our object's origin is placed far away from the center. It won't center properly. We'll have to move the origin to the 3D cursor. Done. Now it's working. Let's look at the spots where the meshes are joining. Let's sculpt the surface and see what happens. Did you notice that line that won't go away, where the meshes meet? We can't even smooth it properly. What could be the reason for this? We joined the mesh, didn't we? Let's look inside. Ouch! What is this? Why is the rest of the arm mesh still visible on the inside? This is why we need to learn how to properly combine the meshes together, to prevent issues like these. Do you remember we had a Boolean option called the union? Look at this inner arm. Let's apply the Boolean. Problem solved? Let's test the arm first. It's working perfectly. Do you see this line here? It will be gone, because the dynamic topology will create new verts around it like this. So, this means we need to manually connect arms and legs with the Boolean modifier, right? Let's do this 5 times in total. What if? Just what if? What if we were to sculpt the compassionate and merciful Bodhisattva Avalokiteshvara with 1,000 arms and 11 heads? How many days will you spend doing that? That will be too hard, yes I know. This is why we have an add-on like the Bool tool. The Bool tool will allow us to select as many meshes and allow us to combine them at the same time like this. I'll share the link where you can download this add-on, in the description below. Let's try again and see how easy this is, by using the Bool tool. Let's apply the subdivision surface modifier for one of the mesh, and the multi-res for another. Again, do you remember what would happen when we try to sculpt a mesh without applying the subdivision surface modifier? We'd get an error like this. Let's try again after applying the modifier. We'll use the dynamic topology on this subdivided mesh. Looks good, doesn't it? Let's remove this mesh for now. I'll cover the dynamic topology sculpting method in upcoming future tutorials. In the multi-res environment, the dynamic topology won't work. Let's leave this alone and just sculpt. Just test the brush and see what they do. Time to create the cartoonish penguin. Let's use this cube. See how I'm making eye holes with Control click and drag? If my brush strength was stronger, I might have already created 2 tunnels. Let's create the character's mouth. Remember to smooth the rough surface with Shift click and drag. Let's create the character's eyes. Let's mirror it. Select the faces like this. We can only allow to select the faces within these 3 edge loops. Ctrl S to move the 3D cursor there and press S to scale Y on the Y axis and -1 to reverse it. Let's move these faces to the back like this. Let's subdivide it. Let's add more edge loops to make the eyes look sharper. We can rotate the eyes with R, because we already have a 3D cursor where we need. Let's use the clay strips brush to add some more details like this. Now I'll demonstrate the difference between the multi-res sculpting and the dynamic topology sculpting. Let's duplicate this head and eyes. Let's use the grab brush to shape up the head a bit more like this. That's how easy it is to create unique characters. We'll need to create their bodies. Let's use the snake hook brush. Remember, we're still using the multi-res modifiers for both. We can create the snake hook brush to create additional geometry like this. In the multi-res environment, the brush will extend the mesh without creating additional verts, and it will be very difficult to sculpt. I'll show you what I mean. Do you see how the mesh is already breaking apart on the lower side of the body? Let's take a look. We don't have enough geometry, because all it did was extending what we already had. If I try to add geometry by sculpting, it won't work well. Think of what happened to a cube when we tried to sculpt it in the beginning. We're only moving one vertex. Let's see what happens when we apply the multi-res modifier and start sculpting by using the dynamic topology feature. The same snake hook brush. Can you guess why we're having the same effect even after applying the modifier? The mesh looks horrible with no new verts being generated. Can you guess what happened here? That's right. The dynamic topology check mark was turned off on its own, and we need to manually activate it again. See that? That's the power of dynamic topology. With the dynamic topology, we can generate new verts as we sculpt. Check out this snake hook brush and how smooth it's extending the mesh so easily. When everything else fails, just create horns and tell others you were creating a demon. Again, this was the main difference between the two. So, please remember to either use the complete base mesh that doesn't need to be modified any further, or use a proper method to add an extension mesh when you're sculpting a mesh using the multi-res modifier. I like this cartoonish penguin character better. Let me change the matte cap. This is the end of the first beginner sculpting tutorial. Please like and subscribe if you have enjoyed watching this tutorial. Thank you for watching.